Welcome to Masterminds in Maintenance, a podcast for those with new ideas in maintenance. I'm your host, Ryan. I'm the CEO and founder of Upkeep. Each week, I'll be meeting with a guest who's had an idea for how to shake things up in the maintenance and reliability industry. Sometimes the idea failed, sometimes it made their business more successful, and other times their idea revolutionized an entire industry. Today, I'm really excited to have Randy Clark here on the show. Randy is the manager of reliability at POLARIS Laboratories, a full-service fluid analysis laboratory and the leading provider of oil, diesel, and coolant testing. Welcome, Randy.
I appreciate that, and it's a pleasure to be here.
We always kick off the show by having you explain a little bit more about your background and how you were first introduced to this wonderful world of maintenance and reliability.
I grew up in a farming community, and I worked on the farms. And I took interest in the maintenance side, maintenance on tractors and farm equipment. You know, it didn't take long for me to realize the importance that maintenance plays on the success of a farm. In 1982, I joined the military as a track and vehicle mechanic. After the military, I continued the maintenance path and worked maintenance in heavy haul transportation, asphalt industry on maintenance equipment there. I then eventually landed in the mining industry where I spent most of my career to date. I eventually moved up to planner and scheduler and quality assurance. And then this great opportunity opened up for a global mining company where I worked as a lead team member of business improvement in maintenance and reliability. My specialty area was component replacement forecasting and budgeting and hydrocarbon management. But throughout that entire career, I've always been involved in reliability and great devotion to fluid analysis and the part that fluid analysis plays towards reliability. About 8.5 years ago, an opportunity opened up at POLARIS Laboratories, and I like to think I helped close the gap that sometimes exists between the language that a laboratory will use and that customers and users may not understand. Today, I have just a terrific team of technical business consultants at POLARIS Laboratories that help support our customers. They continue to help close that gap. They provide training and consulting and help our customers ensure that they're achieving the maximum return on investment of their fluid analysis program while at the same time improving their overall maintenance and reliability.
You know, what is the fluid analysis that you do? What is the importance in predictive maintenance around, lubricant and fluid analysis?
Let me share a story with your listeners. I had a maintenance officer that was just very dedicated and believed strongly in the value of fluid analysis. And I would see him receive these reports from the laboratory. At that time, it was mostly concentrated on oil analysis reports. But he would study these reports and he would use that information to help prioritize maintenance activities. So sure enough, he sent me to the lab. And the lab technician, after introductions, showed me a 3-ounce bottle of oil, and it was a new, fresh, unused oil. He took a little bit of the oil out of the bottle, put it through the spectrometer. Spectrometer done its thing, and it finally printed out a data sheet. And the technician walked back over to me and handed me that sheet. And he said, "Take a look at this. Tell me what you think." So I looked at it, and across the top of the sheet, it had a bunch of different categories such as iron, chromium, lead, tin. Underneath each category was a series of numbers. I said, I just don't understand what this means. He said, "I actually expected that reply." And he asked me if I had a penny in my pocket. I said, "Yeah, I've got a penny." He said, "Well, pull it out and take the penny and rub it between your finger and thumb." While I was doing so, he walked back over to the spectrometer and grabbed that bottle with the remaining oil in it. And he said, "Now, using your finger that you rubbed the penny with, I want you to stir the oil." So I did so. He then took the oil back over to the spectrometer, took the remaining oil in the bottle, ran it through the spectrometer again, printed out another sheet of data. He carried that sheet over to me. He said, now I want you to compare the first sheet I gave you to the second sheet. And lo and behold, guess what I saw? I saw an increase in copper and an increase in sodium. Now think about that. Just from rubbing that penny and then stirring the oil, it was able to detect the copper from the penny off my finger, plus the sodium, the sweat, if you will, off my finger. And I got to tell you, I was absolutely sold on the value after that, because through that little exercise, if it could detect that copper and that penny and the sweat off my finger, just think how early it can detect the earliest stages of abnormal wear in our components. Today's technology is so much better, and we move beyond even in oil analysis, just looking at component health, but we look at lubricant health. And looking at the lubricant health helps us determine the proper drain intervals for our equipment, making sure we're not wasting money by draining oil too early, but at the same time, not making sure we're not pushing that drain interval out so far that acids are building in our lubricants and causing damage to components. We also use oil analysis to look at contaminants in the oil. Contamination of oil, whether it's dirt in the form of silica, reported as silica, can just be detrimental to the component life hours. We can look at coolant, fuel, grease. All these play such a vital part in reliability, and that opportunity to move from a preventative maintenance approach where we're doing things on time-based to moving to a predictive maintenance approach where we're able to monitor the data, say, everything looks fine, let's keep running it, to that point that we see now it's time to schedule it for a service or some sort of component repair.
We think so much about the today. We think so much about like being able to produce product today, but we forget about the $1 million that we have invested in this asset and being able to extend that lifetime by, 2x, it's essentially, doubling the value that we get from this asset. Fluid analysis and oil analysis is obviously just one component of being able to tell the full asset health. And I guess I'm curious, how do your customers utilize different data sets to help really tell a full picture of that asset health?
Well, I'm a strong believer that fluid analysis is probably one of your most early warning devices to see when something's going wrong. The other data sets cannot and should not be ignored. Integrating that data becomes so important. Customers today are getting data from a wide range of sources. They're probably doing ultrasound, thermography, vibration analysis. They're also getting responses back from mechanic and operator walk-around reports. They're doing fluid analysis. And it can be quite cumbersome to go out and look at all these data sets when they're departmentalized. And if you can integrate that data into a single platform and compare data sets side by side, it just gives you such a better picture, an overall picture of what's happening with the equipment, the ability to look beyond individual components or equipment types and see that bigger picture of what's happening with my fleet or all the gearboxes in my facility or all the hydraulic systems, and start looking for common causes of occurrences, getting down to the root cause level and taking proactive maintenance steps to prevent those issues from happening again. It's one of the reasons POLARIS Laboratories developed Data Connect, a great secure way to integrate directly with your maintenance management platform.
All our listeners are kind of at different levels in their maturity of their maintenance reliability program. So I'm curious from you, if you have any tips for someone who wants to set up the beginning foundation of a lubrication fluid analysis program within their company, within their organization. What do they need to be truly successful and very effective with deploying this fluid analysis program?
You can't just decide I'm going to do fluid analysis and simply start pulling samples and send them to the lab and expect a great return on investment. One, it's really important to identify and understand what the goals of your fluid analysis program are. If you're just wanting to monitor component health, well, that's one test package that the lab is going to perform for you. But if you're also wanting to optimize drain intervals, then there's a few more tests the lab needs to include. Make sure you understand the goals that you want, communicate that with the laboratory so the laboratory can be sure to set up the correct test package profile, if you will. Second, I think it's really important for the customer to assign a program manager that's going to take ownership of the program. Somebody that's going to make sure that samples are submitted correctly, that somebody that's going to follow up on the results. For smaller organizations, it might be a shared responsibility. Training is so important when having a correct and a successful fluid analysis program. Folks need training on how to properly take a sample. They need training on the method that the sample will be obtained. Three common types of pulling a sample is a live port sample for pressurized units, a vacuum pump where you use a drop tube down through a dipstick and pull the sample, or a drain port sample where you're just collecting the flow of stream from the oil as you drain the oil. You need a process map of what you're going to do when the sample results are returned to you. How are you going to react to them? What severity levels are you going to react to? And training is not something you deliver once and forget it. It needs to be reoccurring. It's real important when you select the laboratory that you're going to use. There's some questions that you should ask the lab and do some research on. Are they an accredited lab? Are they reliable and repeatable in their test results? Find out about their data analyst. What type of experience do they have? How many years have they been doing this? How familiar are the data analysts with your specific industry? When samples are submitted, it just is so important to make sure you can include the manufacturer and the model and the lubricant name, the lubricant grade. Doing that will make the recommendations and the test results so much more accurate when the customer receives them back. Because if the customer just tells us it's a gearbox, well, that's one set of flagging templates. But if we have it's a gearbox and the actual make and model and the exact lubricant that's being used, that's a whole different world of consideration when the data analyst reviews the results and provides recommendations back. If you decide you make this decision to do fluid analysis and you get these reports back, do something with it. Just think of how detrimental that can be to your program if there's a high severity report sitting in there with a recommendation from a data analyst that says we recommend this equipment be shut down immediately and XYZ be performed, but nobody's looked at that report yet and the equipment's still out running. You've just increased that opportunity for a catastrophic failure to incur. So make sure you're doing something with the data. And then finally, I think it's so important that program champion identify quick wins and share it with the entire organization.
I think one thing that I've seen and heard, a lot of these fluid analyses labs, they give you all this data. They don't tell you what to do with it other than, hey, your equipment's in severe condition. But then the next step is, okay, well, what do we do about it? But it sounds like you guys have gone that extra mile to really understand the equipment, the different modes of failure, and also what your guys' customers can really do to take action.
Ryan, we've got over 8 million statistical data points and fluid analysis reports in our active database. And as you can appreciate, the more statistical data you have on file, the more accurate the data becomes. And we've just got such a great, talented, and experienced team at Polaris that I truly believe we offer true value to the customers.
Randy, I really appreciate you taking all this time today to share some very actionable things with all of our listeners. If our listeners want to follow you in your journey, what are the best ways that they can connect with you?
Gladly give out my email address. It's rclark, no E at the end, at polarislabs.com, or you can always contact me via LinkedIn. Be glad to strike up communication and conversation with you.
Thank you so much again, Randy, for joining us. And thank you to all of our listeners for tuning in to today's Masterminds in Maintenance. My name is Ryan Chan. I'm the CEO and founder of Upkeep. You can also connect with me on LinkedIn. I'm very active, or shoot me an email at ryan@onupkeep.com. Lastly, you can also find me in the maintenance community on Slack, the largest community of maintenance professionals in the world, where we host weekly conversations and contests all centered around maintenance. I hope to connect with all of you guys soon. Until next time, thank you again, Randy. I really appreciate it.
Thank you, Ryan. Appreciate the time and the opportunity.